Hello everyone, so now we are going to discuss a bit about gravitation. So basically what gravitation is, let us deal with some examples. Would you be surprised if you let go of a pen you are holding and it does not fall? Obviously, if I am holding this pen, basically if I just let it go, then obviously it will fall. Then what are the things? What happens if it does not fall? Will you be surprised? Obviously we will, because we are so used to the falling objects that if you just let this pen downward, then obviously it will go downward. It will just meet you on the earth. But what happens if it does not fall? Obviously we will be surprised. So there was one person who was Sir Isaac Newton. What he do? He observed that how the things are attracted towards each other. He concluded that a force that acts to pull the object straight down to the center of earth, that there is something, if this is our earth, so there is acting something or a force that are pulling the things towards the earth center. This is the center and the things are going towards the center. Obviously you have just noticed everything. If you fall any object, that may be anything except the balloon, okay, so just don't mix that with it, because that is something different thing. Any massive object, simply a pen, if you fall it, obviously it will meet you on the ground. So gravity is that force that pulls the object toward each other, and basically in case of earth or in case of any planet we use the word gravity. Basically in some cases we use the acceleration due to gravity, but here we are talking about the gravitation or the gravity that are attracting the things toward each other. If there is a mass m1, there is a mass m2, then they both are attracted toward each other just because of this gravity or the gravitation. Okay, now let's study universal gravitation. Okay, so universal gravitation, why the word universal is given to it? Because this gravitation is valid in all over universe. Okay, so Newton realized that the gravity acts everywhere in the universe, not just on the earth. It is not acting only on the earth's surface but everywhere, whether you are going to moon or you are going to any other planet, your Mercury, Venus or any other planet, between the stars, between the galaxies, everywhere, anything you can assume in our universe is acted by the universal gravitation. Okay, now it is a force that makes an apple fall on the ground. Just because of this force the apple fall down, and it is the force that just because of the moon orbit around the earth. If this is our earth, okay, then moon is rotating toward it or orbiting it just because of what? Just because of the gravitation. Okay, now it is also the force just because of which planets in the solar system orbit the sun. We all know that this is our sun, then all the planets have their particular orbits in which they rotate around the sun, they orbit around the sun. All these things are just because of this gravitation, and there is a constant which we call universal gravitation constant, and that is basically represented by G, and that is your 6.67 into 10 raised to power minus 11 Newton meter square per kilogram square. Okay, so this is a universal gravitation constant that we use in the law of gravitation. Okay, so this, it's just an example or just to make you remind. Okay, now what Newton realized, this is now called law of universal gravitation. The all things, these forces that are attracting to masses is called law of universal gravitation, and this law states that the force of gravity or the force of gravitation acts between all the objects in the universe. This is acting on everywhere, on all objects. If a person is sitting here and another person is sitting here, then they both are attracted toward each other just because of this gravitation. Now this means any two objects in the universe without some exception will attract each other. Obviously there are some exceptions. For example, if we take the example of magnet, then they are the masses obviously, but if you put the same terminal towards each other, then obviously they will repel each other. So there are some exceptions, but the point is that there the come of magnetic effect, just because of it is repelling. But if you talk normally in the universe, any object will attract each other. So you are also not attracted only to the earth, but also to the other object as well. What you notice is that you are attracted to earth, because if you just suppose you are jumping on a surface, okay, then what will happen? After some height you will go downward, then you can see that gravity is attracting you or the earth is attracting you, but you cannot see if a person is sitting here and another person is sitting here that they both are attracting each other, but they are. Every mass, any mass m1 is always attracted to the any other mass m2, and these masses may be anything, okay. Now earth and the objects around you are all attracted very well, okay. However, you did not notice the attraction among the objects because these forces are so small as compared to the earth gravitation, because earth mass is so huge. So larger the mass, larger will be the attraction, and you will notice. Now what are the factors that affect gravity or the gravitation? Two factors that basically affect these is the mass and the distance. Now we are just taking a brief of the gravitation. Basically what the force, that gravitational force is basically is equals to g m1 m2 by r square. This is basically the formula. We are not deriving it, we just want to study what the factors affecting. This is universal gravitation constant, we just studied. This is 6.67 into 10 raised to power minus 11 Newton meter square per kilogram square. This is a constant. What are the left thing? These are the masses and the distance. So mass, this is first object, this is second object, and this is the distance between them. So obviously there remain two factors on which the gravitational attraction depend, mass and the distance. Now mass is a measure of quantity or the amount that matter an object have, okay. So SI unit is, obviously you all know, that is kilogram, and 1 kilogram is the mass of about 400 modern pennies, okay. Now everything, anything, any small thing, you can just assume electron, proton, these are minor particles that we can have. There are more quantities, but on the normal scale we just know that electron, proton is a very small mass, but they also have some mass. The more the mass, the greater will be the attraction, because here, from here we can directly say that this force is directly proportional to the mass, and this force is inversely proportional to the distance. So obviously if the mass increases, force increases, if the distance increases, that it will decrease, because this is inversely proportional. Now because the sun mass is so great that it attracts larger force, which object have greater mass is it will attract more the gravitational force on the other object. That's why our planet orbit around the sun. There we get to know that why the planets orbit around the sun, just because of sun gravitational force, because sun mass is so great it attract all the planets, and that make it orbit around the sun, okay. Now in addition to the mass, gravitational force depend on the distance that we just studied, okay. Now further the objects move, lesser the gravitational, because we have known that force is inversely proportional to the distance, we have just studied. Larger the distance, lesser will be the force, or the lesser the distance, larger will be the force, okay. For a spacecraft that is traveling toward Mars, earth gravitation will pull, decrease the spacecraft distance from the earth increases, okay. Which object have nearby to the any other object, then obviously it will attract it more. Now eventually the gravitational pull of the Mars become greater than the earth, and the spacecraft is more attracted to our Mars because it is away from the earth, and larger the distance, lesser will be the mass. Now this is a rough diagram that the force of gravity act on all the objects. If this is an object 1, this is an object 2, they will attract toward each other. If the mass increases, the force of gravity will increase, but if the distance increases, it will decrease. We have just let it know. Okay, now just understand a basic thing, that is mass and the weight difference. Basically, mass is what that a body or the matter possesses in the body, but weight is a different thing. Mass is sometimes confused with the weight. Mass is a basically measure of the amount of matter in an object, and weight is the gravitational force basically that is exerted on that object. If you are on the earth, then your mass is same. If you are on moon, your mass is same. But if you are on Mars, or you can say any other planet, then obviously your weight will differ. Now the force of gravity on a person or an object at the surface of planet is known as its weight. So this is basically what the weight is, that the force of gravity that is acting at the surface of planet, it depends on the planet, because the gravitational attraction or the gravitational acceleration, your weight is W is equals to mg, where m is your mass of the body and g is the acceleration due to gravity or the acceleration that an planet exert on you. Okay, so when you step on the bathroom scale, you are determining the gravitational force of the earth, because we are on the earth. But similarly, weight varies with the strength of gravitational force, but mass does not. Mass remain constant. Okay, suppose you weight yourself on the earth, that is 450 Newton, or what you measure is 450 kilogram that we measure. But if you travel on the moon and then weight it again, then what we have noticed that you weight 75 newtons. Okay, that is a mass of about 8 kilogram on the earth. So you weight less on the moon. Why? Because the moon mass is only a fraction of the earth. So the gravity is also less. So lesser the gravity, lesser the weight. And this is an example. If you travel on the moon, then weight on the moon is 270 Newton, and similarly weight on the earth of the same object was 1670 Newton. Similar is another example. So their mass, this is the mass example. Mass on the moon is 165, mass on the earth is 165, but the weight differ in both the cases. Weight of any object will differ. Okay, so these are the basic concept of the gravitation and the gravity. Okay, so thank you so much.